A quick video about some toy alternator play here. This is a KidWind stator that was 3D printed. It's a stator, it's to place the coils in. These are 4-inch diameter discs made of 1-inch steel. These are those common magnets. I think they're 1 7/8 by 7/8 by 3/8 of an inch thick. You can get these at hardware stores all over. So playing with these today and thinking about the best way to use them on these 4-inch discs. To really use the magnet, you can't put them in this way because you couldn't use this part of the magnet because there's got to be room here for some copper. So logical way to do it is put them in sideways in this configuration. If we want to build a single-phase alternator, the hole in the coil really ought to be the size of the magnet, which this is. So to fit in here, the best I could do, in this case we've got 180 turns, I think. I wound these coils a while ago, so I'm not sure, but I'll know in a moment. Of 21 gauge wire. If we use 24 gauge wire, we could have twice as many turns, 360. If we used 27 gauge wire, we could have 720 turns. So voltage is directly related to the number of turns. So you see how that fits. If we wanted to build a single phase machine here, we'd put these in like this. And we could only have 2 coils. And these could be wired together in series or parallel, but if it was series, you'd hook the inside of one of these to the outside of the other one. And you'd have positive and negative on the other ends. Or, it's AC, so you'd have double the voltage. But that's a pretty good fit in this mold. Quick rundown, this is my 21 gauge wire. This is my coil winding setup that I 3D printed. As you can see, this is for the center of the coil. When I put all this together with the center, this is exactly the size and thickness of the magnet. Generally, I make the thickness of the coil the same thickness as the magnet. When I wind a coil, I came to 180 turns, determining the maximum size of the coil. So on the first coil, I can use these and kind of rub it in here while it's still in the winder to know that I've hit the right width and length, and that's when I stop. And in this case, I stopped at 180 turns. When you take the coil out of the winder, it will puff up. It'll get thicker. So while they're 3/8 of an inch thick, all pressed together, you take them out and they get fatter. So what I do is I sandwich them between wax paper. First, I lay wax paper down here on this plate, and I put super glue on it. I use this tight bond cyanoacrylate. It says wood adhesive, but really it's just super glue. And I put the coil on that, and then I put super glue all over the top of the coil, and I wrap the wax paper over the top, and I smash it down. I've got spacers in there to make sure that this comes down to exactly 3/8 of an inch thickness. In this case, I used a couple of magnets, the same magnets as spacers. So the coil will be exactly the thickness of the magnets. I use the press to do this. You could use a vise or C-clamps or anything. The press is just handy for me. So I'm going to open it up now, and hopefully the super glue's dry. And there's the coil. And this coil is nice and hard and formed, so it's pretty sturdy, and the thickness is perfect. So I'll take that over and see how it fits. So my recollection here of 180 turns is correct. It's the same size as these other coils. So now we could see how three-phase fits into that mold. I think we can do three-phase. It might be a little bit tight. It is a bit, well, you could, yeah, these coils won't quite fit for three-phase. Could get rid of a little material. Oh yeah, they will. Yeah, you can smash them in there. Okay, so that'll be a three-phase setup. It's really tight with 180 turns of 21 gauge, but it did fit. But you can see it's not falling apart. A little bit of glue and that would hold together nicely. So now what I can do is test one coil against 4 of these magnets on a rotor and get some idea of the voltage I'll get per RPM out of one coil, and then we can kind of figure out how we might get desired results and adjust the number of turns of wire and go from there. Over here I've got a test rotor. When you spin these fast, the magnets will want to fly out, probably even if you glue them down. So I've turned this, not turned, I 3D printed this little cage that I can glue on there that'll hold these magnets in. So I can glue all that together now, and those magnets will never fly out. To test this, I'll put this in the mill. You could use a drill press or whatever. And I'll glue one coil to this tester, and I'll put it in the vise, and then I can run it back and forth. When I made this, I glued a 2x4 to a piece of thin plywood. I want the coil in here so that if I want to make a dual rotor, set up 2 rotors, one on each side, it'll be very thin and I can slip this in between. So I'll need to cut out here for the coil and glue it in. And I want this square so that when it's in the vise, it's not crooked, because I want the gap between the magnets as thin as possible. So when I glued this together, I took some care to hold this square while I glued it. And again, I used the super glue to glue it with, and I held it all together tight while I sprayed it with the activator. The activator will dry super glue immediately. Pretty handy stuff if you don't have it. So I just traced the outline of the coil on this thin piece of wood, and I'll cut this out on the bandsaw here. And then I'll use super glue and activator again to quickly glue that coil in there, and I'll glue it in square so that when I test it, I can keep the air gap, in other words, the gap between 2 magnet rotors, as thin as possible, because flux, the magnetic field strength gets weak very quickly if you get away from the magnets. So you want the coil flat and square and running as close as possible. Okay, now that's cut out. I just have to glue the coil in there. So now that's setting up real quick because I used the super glue and the activator, and I'm holding everything really flat. So when I test it, it should be reasonably flat and square. Also worth noting, I did this glue operation on top of wax paper so I don't glue it all to the table. I've also put a bit of glue on this to keep it from falling apart. So the magnet shouldn't slide around now, and should all be ready to test. I'll just have to strip the wires and chuck this up in the drill over here. I'll put it all together and I'll make another video here in a bit with the test results.